right, welcome all of like 40 of you. Thank you for actually showing up. This is reverse engineering DLL files. Okay, just a show of hands who actually knows what a DLL file is, or they've probably seen it. Yeah. So they always tell you like, don't touch those, don't delete them, it's gonna screw everything up. Don't go to system 32 and just start deleting. But it's okay. This is what we're gonna cover. We're going to do a history of DLLs and what they are, how do they work, and then all the little intricacies of it before we finally dive into reversing. The reason why we're doing this is because you can't just jump right in. You really have to know what it is and how it works before we can reverse it. This is true of just about anything. You don't just like start pulling apart your car if you don't know how to put it back together. All right, these are the tools we're going to be using: IDA Pro, CFF Explorer, the PEL-C compiler, x64dbg, Ghidra, and Process Hacker. All of these tools are free with the exception of IDA, but that's still free, sort of. All right, first off, what the hell is a DLL? All right, way back in the day, I'm like Turkey, I'm talking like way back in DOS days. This is a time when there were COM files, these little tiny files. They were limited to about 64 kilobytes of data. You really did not have much space to work with. I remember there was these old books, right? And if you wanted any code, it all had to be statically compiled in. It would be like a floppy disk drive. It'll have like a zip program inside. And what you would do is you would copy and paste the zip code, and then you would just work with that. Size was limited, space was limited. Like I said, 64 kilobytes isn't much to work with. And you just kind of rolled with that. It was really the dark ages. So, enter dynamic linking. I mean, the same thing with Linux and Unix kind of showed up around the same time, but it changed everything. What we could do is we could rather than statically linking everything together, we could actually break up the entire process. You know, I don't have to have one program responsible for doing zip files or opening like special database files or whatever. I could break everything up so that way I could focus on just my program and let someone else do whatever. So this allowed, programs to be bigger and more complex. So this is pretty much how Windows did it way back in the day. Well, let me go back. I want to talk about that a little more. So way back in the day, so like Windows 3.1 and version 1, they had this thing, it was called GDI. It's like the graphic desktop interface, and user.dll, so user. So they were all executable, so they were basically like dynamically put together. The only way Microsoft had figured out, all right, how to like layer stuff in such a way that they could like have a GUI is like, there's no way it would all fit on one executable. They had to break it up, and this is how they did it. All right, how do DLLs run and load code? Well, a program, is written and compiled as a DLL file as a compiler flag. See, functions are set to what's called exportable. So that's kind of like how a program breaks it up. You can't, you'll have a function say zip or encrypt or something like that. And what they'll do is they'll take this particular function and they'll break it up and they'll set it as exportable. They do that in order for other programs to be able to call that particular functionality. Okay, program B. Well, I basically just said that, but you call a number of Win32 APIs, like load library. All that does, as it says, it loads a particular library. We call a function called getProcAddress. What that does is it takes basically like the name or an ordinal of like a function, like say I have Kernel32 and I want to, I don't know, zip a file. I know I keep calling zip, but zip changed everything, Compression back in the day was crappy. They had this thing that's called Hoffman compression. Anyway, I have any idea what the hell that is? It was more like encoding. You'd have like, say a text file and it would look for like characters in repetition. And it would instead of having like AA, it'd be like 2A. It was really crappy. So someone who came along and said, let's zip it, just changed everything. Anyway, going back to load library, getProcAddress. So getProcAddress just allows us to pick the particular name of a DLL exported entry. So Program B will create the function prototype and call said function. There are a ton of different ways to load DLL code, but the traditional way to do it is via the instantiation of another program. DLL events. Okay, so a DLL is like a C program or any other program. It'll have what's called a main function. So the main function is like the first thing that gets called initially when you first load it. The difference between a DLL file and a normal executable file is the code inside the main is optional. There doesn't have to be anything. So I thought that was pretty cool. It's like, yeah, what does your code do? Nothing. But, okay, so there's these events, right? So an event, so you can have like events when you first fire off an executable. Like the events won't actually fire until you instantiate the DLL file. So there'll be like different kinds of events. Okay, these are the events. The event one is process attach. So when you call like load library, this is the code that gets executed first. Thread attach happens whenever you instantiate a new thread. DLL thread detach, same thing, but when the thread is destroyed. And process detach whenever the code is done. So I found, I know it's kind of like blurring off of here, but it says bug at the bottom. I found that the process attach event goes off several times once load library is done. I think it's like a bug or a thread thing, or I don't know, Microsoft never fixed it. Okay, so this is what the code looks like. I don't know if it's kind of hard. I tried to blow it up as much as I possibly could without it making it look too much like crap. All right, process attach. When I first instantiate the DLL file, this is the first thing that's going to go off, because once I call load library, that goes off. When I'm done, when I call free library, the second part's going to go off. And then the last part here is my exported function. I called it jofunc. Oh, okay, imports. This is where it gets really complicated. And I try to not make it as complicated, but it's essentially part of the Windows operating system. So the concept of dynamically linking things goes back to the import-export process. So you'll have a program, right? And you can't you don't really want to like statically compile everything in. So you'll take certain functions that you want and you'll import them. So in this particular case, I don't want to statically compile in everything from WinInet. So I just want internet close handle, internet read file, etc. So it's just like the imports are just like a table of all the functions you want. And typically the imports will be, imports can be either in an executable or in a DLL file. Rather than statically linking everything in, which would make this really big, massive file, programs make use of imports. All right, exports. These are the most useful ones. So a DLL file can optionally, but usually have an export. That is, if you want actual code for other programs to actually utilize, you have an export. So programs will use said DLL files, and sorry, let me start again. Programs that use DLL files are mostly interested in not the events section, but rather the code that's exported. For example, here we see CRC32, the cyclic redundancy check. I have not used that in so long, but it's exported from a particular DLL file called libmupdf, and we see the appropriate file it's associated with. So, like I said, functions right here, they're either called by name or by ordinal. Okay, ordinals. So, sometimes if you ever open up a program here, you'll be like, what the fuck is this? It's like, you don't see the name, you just see a number. So, git proc address, it doesn't care. I mean, when you load library or instantiate a program, you can pass what's called like an ordinal, which is just a number. It's a 32-bit number, and it's representative of a function. It's confusing. It's kind of a form of obfuscation, but not really. Okay. Like I said, it's more of a reference than an actual function name. And as I said, it's all a 32-bit number. In this particular example, we'll see, did I have that here? Oh, yeah. We'll see winsock with no names instead of numbers. And you'll see numbers instead of names. And you're like, what the fuck? But the exports, you can actually look them up. If you were to actually open WinSock32 and follow along, you can actually see the different names associated with the numbers. So in this particular case, you can see hint 36, and where the fuck did it go? Yeah, my bad. Okay, sometimes, I'm sorry to skip over that, but basically it's just a name. Instead of having a name, you have a number, and it's easy to bypass because you can just look it up. Okay, sometimes, once in a while, you look at a DLL file and you see something like this. Okay, what this means is sometimes, there's lots of different DLLs that have been added over the years. This is Microsoft invented this thing called COM files. COM files are just a entire fuckery and just total madness. In the heydays, when they thought we're going to use Internet Explorer for everything, we're going to use ActiveX for everything. They said we're going to use this. We're going to use objects and names and references. It didn't make any sense, but they're still around today, and you'll still encounter them all the time. But if you see these exported functions, just run away screaming. But you'll see these four instantiations. So as I said, OLE COM, not to be confused with DOS COM files. OLE stands for Object Linking and Embedding, and COM stands for Component Object Model. Like I said, ActiveX madness. I ain't touching this rabbit hole. If you're interested and you're crazy, you can actually download a tool. It comes with Microsoft, and it'll tell you all the craziness about all the little functions and how to all call it. We've been trying to get away from this. Microsoft invented .NET, to try and step away from this, but it's still there. Once it's there, it's never going to go away. It's like a feature, something gets built in, like an example would be, I don't know, like some guy at the airport 20 years ago from now, actually, he tried to light his shoes on fire, right? And to this day, I still have to take my shoes off at the airport. It's embedded in now. We can't get rid of it. Okay, calling our DLL code. Okay, like I said, there's many, many different ways to call our DLL code. And when I say many, I'll get into those later. But like I said, the traditional way is with get proc address and load library. There's also this thing called run DLL32, which I'm sure you've heard of, maybe. I don't know. But as you can see, our C code, I also included C# code because I like C#. But you can see right here, load library with our library name, checking to see if it worked, our function name, get proc address, our export name, and we call it. So in a traditional program, it'll fail, it'll fuck up if you don't know if you don't know the arguments that get passed to it, then it'll fuck up. It'll give you some compiler error. DLL files are a little bit different. It's all blind. You have to know what goes in and what comes out. So it's a little more unforgiving. But this makes it ideal for reverse engineering because we can blindly throw our data at it and see what comes back. Okay, run DLL32. What? Okay, so run DLL32 is what's used for calling and running exported DLL functions without writing our little wrapper program. So when I say wrapper program, I mean something like this. So if we're too lazy to write this, we'll use run DLL32. So the syntax is just basically run DLL32, the name of the library, the function arg. It's not really particularly hard. You'll see it used by installers, malware, all sorts of things. Okay, so run DLL32 as an execution order. Like I said, when you instantiate it, it'll first run the code that's in the process attached event, then any particular exported stuff, and then the detached process events. And since threads aren't used, then you're not going to see that. Okay, so this is an example of a program, a DLL program. Run DLL will run this first, then second, if there's anything in there, and then the last one this. So I just have a quick example. Run DLL32, and it'll run, executes this first, the next window will say second, and the last one, yeah. Okay. I know, we are anonymous. You remember that? Yeah. Okay, so DLL files. When you they have what's called a search order. So a DLL file will not particularly just a DLL file will it'll run things from certain locations. It can be exploited, but ideally they run from a in a particular order. So if you drop a DLL file into the directory, most likely it'll run it, but sometimes not. But it has a particular order. First one is, if it's already loaded into memory, then it's just going to load from there, because why wouldn't it? Next, it'll read from something from what's called a manifest file. Then there'll be what's called the known DLLs directory, then the launch folder, the current folder, the system folder, and then finally the path. Path, you know, throwback heyday, trying to do that compatibility, you know, with like Unix system, POSIX, whatever. But that gets executed last. Okay, known DLLs. Known DLLs, it's a particularly, so people have been trying to exploit this whole thing for a while. And Microsoft came up with this idea, all right, let's have a list of DLL files that if you try and sideload your shit, then it's not gonna work. So, the known DLLs registry key will contain a list of DLL files here that you cannot sideload. So it'll conclude, so if you try and like load your own system, if you try and load your own Kernel32, it's not going to work. If you try and load your own user32, it's not going to work. I think they did it also for like compatibility. Also, you know, back in the day, there were if you were to run like Windows 95 Kernel32 with Windows 98 Kernel32 would just fuck everything up. And they're trying to like say, oh, let's not do that. Okay. So it's also like a minor form of security restriction, but well, not really, not always. Okay, again, it's hard to read. It's like you have to blow everything up. But there is a list here of all the different DLL files that you cannot sideload normally. So like COM32, GDI, image help, Kernel32 is obviously there, PS API. This is just core functionality within Windows. Like WinSock here is used for pretty much sockets. Shell32 for ShellExecute, Windows stuff, bunch of stuff. They don't want you fucking with it. Okay, exploiting the search order. You can actually exploit this, and you can get vulnerability money for it. There's a number of CVEs out. What you can do is if you can load your own code, basically you're sidestepping the entire process. You see, if you have like a program that's signed, or you have unsigned code, you want to make it signed, or something is running elevated and you want to make it elevated, you drop your DLL file that you wrote, and the program will actually execute it on your behalf. Since there's a number of DLL files that are not in this particular, since there's a number of DLL files that are not in this particular list but are still called, then we can exploit it. So an example would be like version. A lot of programs will use a DLL called version 32. A lot of modern programs use this DLL called VS, it's like VC 140 version something or another. It's basically a DLL file that gets included by compilers, you know, for that backward functionality. But since it's not actually in here, we can drop our own and we can exploit it. So an example here, I have Final Fantasy. We have an install here. You can tell if something's elevated because it'll have that stupid, it's kind of hard to see here, but it'll have that little shield next to it. The shield represents like this is an admin program. If you can sideload an admin-only program, something that's elevated, now your DLL is elevated. So it's a form of privilege escalation. Also, there's a bonus if something is signed and trusted. It'll also get around Smart Screen. You know, that little thing that pops up, the UAC thing says, "Hey, this is a problem," or "I cannot run this because I don't trust it." You get around that if you sideload a program that's already like trusted. Okay, redirection. Now I said before about known DLL files and not being able to load like your own user32. Microsoft came out with this thing, manifest files, and basically it's XML code. All the original, so newer executables will contain this little tiny bit of XML code, and the XML code is responsible for specifying things like this program should run as an admin. Like if you add the entry for admin, then magically the little what's it called? The little shield, that's what it's called. The little shield will appear. Older programs do not have a manifest file, but Microsoft, you know, it doesn't care about that. Actually, it's funny, when you run an older program, Microsoft will automatically will automatically tag the file with a manifest file, but like it does so internally. So it doesn't actually modify the file, but it'll memorize like, hey, this is a manifest with it. Like I said, it's a relatively new feature, but there's certain elements of the XML file that we want. The file entry tag allows us to specify our own DLLs, and this goes at the very, very top of the execution order. So if we want to load our own Kernel32 or user32, we do it with manifest. So, sorry here, I'm trying to like talk at the right volume. Can people hear me? Should I like talk like this or should I talk like this? Okay. All right. All right, I keep using this CFF Explorer program, but it is by far one of the coolest tools for viewing DLL, or for viewing executable stuff. Like it'll have all this stuff, like the different headers, imports, exports, resources. So like resources will be like, you know, icons, pictures. You can actually steal those and use them in your own program, and this is how you do it. But anyway, you can actually view the manifest file. The manifest file here will have all the different informations. This McAfee UI controller, handler, whatever. But you can see right here, request privileges. It wants to be run as administrator, otherwise it won't run at all. So it'll have that little shield next to it. But what we're really interested here is the file one. Where the fuck is it? Sorry. Well, you're just going to have to take my word for it. There's going to be like a little thing that says file on it, and we can include our own. Okay, hooks. I know this is like, it keeps getting complicated, more and more complicated. I'm sorry my talks get so complicated, but there's always this like, you have to know this, and you hope to know this, and you're like going in blind, you don't know how to code, but it's okay. Well, anyway, so Windows, in their infinite knowledge, you know, they've provided functionality to alter and monitor their internal subsystem and environment. So what this means is like, if I want to monitor like whenever someone like opens a new window, then I can perform my own actions. So this can lead to a lot of madness, you know what I mean? So someone opens up a new window and then I draw a box that shows a smiley face. I don't know why I would do that. Maybe an old school virus would do that, but whatever. So there are a number of callbacks that utilize this particular function. The function here is called setWindowsHook. And like I said, it allows us to monitor this stuff. So we can actually monitor a number of things like the keyboard, the mouse. So why would you hook the keyboard? Keylogger. Sorry. The caveat here is you can only hook certain things. You can only hook stuff within your own within your own address space, but you can bypass that with DLL files. So one thing I have not talked about, and I don't really want to jump down that rabbit hole, is the entire system or functionality within Windows is these things called window messages. Microsoft, in their infinite wisdom, has decided to devise this system of what are called window messages. Things will get passed around all the time. So something like a new window is created, or you scroll your mouse or whatever, a certain like event will fire off, and it'll be like a window message. All the hooks do is they follow that window message, and inside will contain the data you want. But yeah, I'm not going down that rabbit hole. Okay, shared memory spaces. So in the basic Windows model, like a process will have basically access to its own address space. It can't fuck with other address spaces, because if you go back to the DOS days, everyone just shared their own address space and everything was supposed to be like, please don't screw with mine. There was no trust involved. Microsoft comes along and says, all right, let's make it so that way programs have their own address space and they can't fuck with each other. If you saw the old, back in the days of like Windows 95 or Windows 98, you'll see like a blue screen of death. Basically what that was is it's something violating the trust and writing from one user space to another user space. Typically like user space in the kernel space or back and forth. But programs try to adhere to the concept of this is my address space, don't fuck with it. So, DLL files, we can actually bypass this by including what's called our own shared segment. If you instantiate a particular way, if you instantiate your program in a particular way and include the little shared section, your DLL file can now run in the address space of other programs or the entire system. So the way we would do this, for example, if we want to use a keylogger and work on everything. This is one I wrote. I don't know if you can write that down. I'll be handing out the slides soon. But like I said, a keylogger, if you can get your DLL code to run in every other address space, then you can log all the keys of everyone. And this is basically how keyloggers have worked since the start of Windows 95 and on. I mean, I remember the NSA has come up with other ways. Like for example, direct input. Direct input, you know, it's like direct input is like, I'm kind of going off topic here, but like direct input is like you have a key, like you have like a controller or something like that, or like a joystick or whatever. A direct input actually controls that, and it'll actually monitor the keyboard for you, and you can watch that, and it'll bypass everything because who the hell is going to exploit, you know, like, yeah, DirectX? Only a crazy person or the NSA. Okay. More and more madness. I know. App-init DLL files. Yeah, so imagine you wanted to, say, take a DLL file and have it running in the address space of everything without running any code. They have this thing called app-init DLL files. It's an interesting functionality. It was around, you know, they introduced it around Windows 98, and then they took it away around Windows XP, I think. No, probably Windows 7. Basically, what you could do is you could specify your own app-init DLL files, and anything that instantiated user 32, which was everything, or almost everything, anything that's not a console program, and it'll load your code, and you can do whatever you want with it. But of course, this can cause lots of madness, lots of instability, and everything will break. So this used to be super popular with malware, but it's since gone the wayside since this feature is now turned off by default. There's another one. Of course, like I said, Microsoft in their infinite wisdom, they keep adding stuff, breaking everything, making it easier for us malware writers to just go nuts and go ham. So there's another way. Microsoft said, well, what if we want to hook everything, not just, you know, like, not just things that run user 32, but everything. So they came up with AppCert DLLs. So basically, the way you instantiate, you look for this registry key here. You go to the session manager, you create a new entry, you type it in, and it runs. Sorry. The thing about this is it's not off by default. All you have to do is re-add the registry entry, and boom, there it is. And again, this will fuck everything up, or can. Okay, DLL injection. Again, has anyone heard of DLL injection? Maybe in like a class or something like that. It's like, what is that? What the fuck is going on? Okay, so since I said the traditional way, quote unquote, to instantiate a DLL is, you know, like the get proc address load library way. But there's great people over the years that come up with crazier ways and crazier methods. And Microsoft, of course, in their infinite knowledge, is, you know, giving us methods of doing it. So these are the most popular ones I've come across for injecting your own code into other stuff via a DLL file, but the most popular ones are create remote thread, create thread again. So this one, for example, so Microsoft, the way they work is there'll be like a top level like DLL name, and then if you go lower in the system, like NTDLL, then it'll have this, and if you go even lower, it calls this. So basically, sorry, that's confusing, but at the very top, if you call this, internally, Microsoft will call this, and internally further, it'll call this before it goes into the kernel land. But anyway, you can use those to exploit and run DLL code in other programs. Okay, does it sound hard? It's because it is hard. I mean, this whole thing is hard, but it's like, there's a lot of involvement into actually running your DLL code into another program, because it's not normally done. So like, for example, first you would like assign yourself a privilege token because you can't normally write into another program's address space, so you need the debug privilege, then you need to call this function, then this one, then this one, then this one, this one, then it works. You know, I could make an entire talk on that entire subject, but I don't want to. This is different. Okay, so if you actually want to follow along, I don't though, but you would open the process, you would allocate some memory inside the process, you'd write the process memory inside, you'd call this, and then it would run your code. Now, the reason why a program would typically want to use this particular method is maybe like cheating at something. Cheating at video games is popular. This is how you would do it. You drop your code inside and you run it, and no one's the wiser. The popular reason why you would do this is you're not going to modify a function. You know what I mean? You're not going to modify the program. Modern programs now, they care. They're all signed, you know. And if you try and modify a program that's signed, now all of a sudden this trust is broken. It won't sign. It won't run. But this is how you do it. This is how you run your own code inside of a signed program. Okay. DLL, etc. Blah, 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 blah. All right. The last thing I want to touch on is Kernel32, NTDLL. These are the base components of Windows. I don't know if I said this, but most, if not all, of Windows functionality all stem from these particular DLL files. NT.DLL is considered the like lowest of the lowest of the low. It has all the wrapper functions from all three of these, but they're unsupported, or officially from Microsoft, they're like they don't exist, but they exist. Functions within NTDLL file will be like either start with NT or ZW. I don't know what ZW stands for, and people have been speculating for years, but I don't know. Take your own guess as to what ZW means. Anyway, at the lowest of low level, you'll see like DLL calls like exports. You know, like it'll start with it could be like NT write file. It could be ZW create file. It could be like NT create thread, 8 NT message box, or something crazy like that. Now, if you're actually interested in jumping down that rabbit hole, there's a group out there called ReactOS. This particular group, they've been trying to break down Windows and reverse engineer it for years, and they've made a lot of progress. You know, they actually have a program, a version of Windows that'll actually run and boot and everything, and they've managed to completely reverse engineer the entire project themselves. Quite impressive, even for me. Yawn, yawn, yawn. I know I can go over this crap all day long, but this is essential, you know, to reverse engineering stuff. If you don't know this at the most deepest of levels, then this isn't really going to work. So we all know that DLL files can be reversed dynamically by looking for load library calls and get proc address calls. We know that exported DLL functions are imported by executables using, again, DLL proc address, and we know what the little events are. Once we know all this, then we can actually start diving into reverse engineering. Now, as I said before, the reason why we would even attempt to reverse engineer a DLL in the first place is, like I said, things are broken up, and if you want to take functionality from one program and put it into another, we would reverse engineer the DLL. So, going back to the ReactOS, I said over here, or even the early days of programmers, you know, like we actually can attribute things like LibreOffice or OpenOffice or whatever they're called now to pioneers in reverse engineering actually taking like Microsoft's Office and Word and like reverse engineering and taking their functionality and putting in their own and like not telling Microsoft and running it anyway. Okay, that did not turn out as well as I wanted because there's a conversion. Like I said, the OpenOffice people, they try. It's not reversing isn't an exact science. People try, but this is as good as they come along. This is OpenOffice Impress, and this is attempting to run a PowerPoint. It works, but kind of. Okay, so when it comes to reverse engineering programs, the big ones, the big two, these are decompilers or disassemblers. There's Ghidra and there's IDA. Those are the big ones. They've come out. IDA is tried and true. It's been around the longest. Ghidra is written by the NSA. I guess it's fairly recent. Ghidra is nice because it's free. IDA is also free. It's floating around out there. I'm not going to say it's on a torrent, but it's out there. Ghidra is free too, but again, it's written by the NSA. A lot of people don't trust the NSA. I don't trust the NSA. Okay, POC or get the fuck out of here. Okay, so I started going through my computer, which I've had a few years, and just piling through all these DLL files, wondering what looks interesting to reverse engineer. So I was actually, I forget, I was running some game or something. I think I was installing some emulator, and it installed McAfee for me. I hate that. You know, you buy a new laptop, it has all this shovelware. You know what I'm talking about, right? Like Candy Crush or whatever the fuck. They always seem to include McAfee. I don't know. Does McAfee just sell their soul, or does other places sell their soul and McAfee dumps all this? I don't know. Anyway, these are the DLL files we're going to actually be attempting to reverse engineer. We have McDLL, probably McAfee and not McDonald's. We have CPU utility, which is used for, finding information on internal stuff. I don't know if you've ever used a program called CPU-ID, but gamers will actually use this to get information, like say, this is my program and it has these drivers and I need the latest drivers so that way I can have the absolute best program, absolute best performance or whatever. Or people will use it to, brag on forums or Reddit or whatever, saying my computer is better than yours. They would use a program that's called CPU-ID. I should really bring that up, but oh well. Anyway, and finally, I was going through ASUS, and ASUS has, again, they're a hardware computer company. They're a hardware company. They produce, motherboards and not processors, but mostly hardware. I came across this DLL file. I'm like, that looks interesting. So let's reverse some shit already. Okay, CPU util from the CPU-ID company. Now, when I look at the exports entry, there's 3 entries. CUL or CUI in it, or I don't know what. Is that an L or an I? I don't know. CU update and get number of processors. Okay, so what does Ghidra say? Ghidra says when we attempt to reverse engineer the process, we see a pointer to a structure. We see the pushing of said structure onto the stack before calling this particular function. I know it's kind of hard to see because, Impress and Microsoft's PowerPoint, they don't always come together, so it moves some of these around. But this says get native system info. And the internal documents for Microsoft's get native system info is this. This is just, ignore it. God, keep screwing all of that up, and I'm sorry. All right, so when we're reverse engineering stuff, it's never easy. It's always a pain in the ass, but sometimes you'll get lucky. In this particular case, going back to our get native system info, we know it's a structure because it's being called by an address instead. Typically, you won't typically call your structure directly, like in a register. It'll be placed on the stack or something like that. You'll call it by reference. Anyway, according to MSDN, which is a great source for everything, there'll be the particular function that we see being called get native system info will actually calls that structure right here. And you can actually look up the structure right here and what it does and how it works. So the function here, what it'll do is it'll fill up the structure for you. You instantiate the structure, and it fills up the little the structure for you. I mean, you instantiate the API, and the API fills out the structure. And if you look down, 7th one down, get number of processors. Pretty easy. Don't have to do anything. We already know. We know how it does it. And if we wanted to do it ourselves, this is how we would do it. Okay. MC delete files deferred and MC and yeah, I guess it's from that. Sorry about that. McAfee. This is the DLL file. This is the actual program. This is the export name. Okay. So the first thing I do whenever I'm attempting to reverse engineer anything, I'll drop it into IDA or I'll drop it into Ghidra, and I'm going to take a look at how it works. Usually, a lot of the modern disassemblers and decompilers, they'll take a lot of the work out of it for me. They'll tell me what kind of data it thinks it expects. It'll tell me I think it's using this structure. I think it takes this. So when I'm reverse engineering something, I don't have to make that blind guess. IDA's already done a lot of the work for me. Not all of it, but some of it.
we can actually follow along a little bit in our disassembler. The beauty of reverse engineering DLLs is that I don't always have to dump into the debugger. A lot of the times I can just follow along in the disassembler and kind of get an idea of what's going on. So in this particular case, MC, McDonald's delete files deferred or whatever, it seems to be calling a function called find first file. Well, that makes sense because it's, deleting files. If we're successful, I know it's hard to follow along with assembly code. It actually makes a lot of sense when you actually mess around with it long enough. We're jumping to here, we're checking to see if there's a file. If so, then jump to this, and then we call this. Yeah, easy enough. But if we dive in, we can actually see this particular function here called move_file. Move_file_ex, again, it's been a great program. So have you ever had I don't know, have you ever used a program, if you've used Windows and you've tried to delete a file and it says it won't because it's in use, it sucks, right? Microsoft has come up with a way to actually get rid of that file. You call move_file_ex, and what it'll do is it'll just move it to another directory or another location. We can actually specify the recycle bin or something like that. And then this little flags here, there's a little flag for it called move file until reboot. What that does internally, it marks it saying just before the computer shuts down, then move it. The idea is it's no longer in use and you can remove it. So going back to our function, move file deferred, that makes sense. It's going to delete the files, it's going to defer it to a later time, and internally it's using move file. Easy. As I said, thus far we've been lucky enough to get away with just using the decompiler/disassembler. However, it's one thing to decompile something, it's another thing to actually jump in the debugger. I know debuggers suck, but it's the only way. I prefer this program called x64dbg. There's others that have been used throughout the years. All the old school tutorials on YouTube, they'll use OllyDBG, which is dead, no one uses it anymore. And there's Immunity Debugger, which is dead. And there's another one I kind of shut, it kind of like went off, but there's there's the one that comes with IDA and it sucks. GDB, it sucks. WinBag or WinDBG, it sucks. I don't like them. Some people use them, but I think you're crazy to use them. This is the best one, in my opinion. Like I said, before we can just start reverse engineering a program, we need a way to actually instantiate the program. I've written a small little skeleton program that pretty much does the same thing. It makes it easier to just drag and drop and run our code. This is our skeleton program. As you can see here, I tried to make it as simple as possible. We're instantiating our DLL file. We're calling load library to load it into memory. We're instantiating the function prototype. We're getting the proc address of the function type. I throw in a bunch of nops so it's easier to find, and then I call my thing, and then I return. I like that return leap. Yeah. Okay, so ideally if we have a function and we're trying to reverse engineer it, we're going to have to single step into it. Well, you single step into a program to kind of get an idea of what the program's doing, and that's how we do it. You can't, if you were to just step over the thing, it'll just crash or whatever. We have no idea what it does. So the idea is we jump into our debugger and we step in and we see what happens. When we start throwing random data at it, it might crash, it might not. If you pass an integer to a program and it takes a string, it's probably going to crash. Or you say you send a string and then you don't send the right one and it crashes. So it's all about trial and error. Okay, so I come across this program. It's called McDonald's ShellExecute. Like I said, the first thing I do is I load it in. I can show you why IDA is better than Ghidra here. As you can see, IDA says, I think it's taking a wide character, like a character array. Ghidra thinks it takes a short. A short is like an integer. I don't know. See, that's the difference. Like I was saying, I pass an integer, it crashes. I pass a string, it works, but it also crashes. But this is why IDA, in my opinion, is better than Ghidra. Since it says ShellExecute on it, it's McAfee ShellExecute. So it means if I run mine, I'm no longer running I'm not running ShellExecute on my box, I'm running McAfee's. So Please don't log my malware. I'm running it on McAfee's behalf because McAfee's not malware. McAfee is the malware finder. Anyway, MSDN is your best absolute friend. It'll contain all the info on all the stuff, and you can follow along with what things take and what things do. ShellExecute, very popular functionality. It lets us do a lot of things. It lets us create processes. It lets us go to web pages. Those are the big two favorites. And this last one right here, NCMD show, that's like whether we show the window or not. So you could literally instantiate command prompt, run some commands on it, and not show anyone because it's now hidden. Okay. As I said before, when I'm reverse engineering something, I want to be able to find stuff. So if you go back to my program here, I added what's called a NOP sled. That's kind of a popular thing with those, those hackers and buffer overflow writer people. But I find a NOP sled easy to find internally in a program when I'm single-stepping through it, just so I know what the hell's going on. Even if I wrote the program, I still can't always find where the hell things are at. But anyway, you can see right here, this is our instantiation of the same C code. Load library, get proc address, take it, run it. So what I'm going to do is I'm going to pass it some data, and I'm going to single step into it and see what happens. So towards the bottom, we see our call to ShellExecute. We can see ShellExecute here is taking something called open. If you were to refer to the documents, which I didn't include because I'm an idiot, but the documents show that run means it'll take like run means it'll attempt to open a program, like from the, basically if you're like trying to run something at like the command line or not even the command line. 10 minutes? All right, I'm speeding it up. I'm almost done. Okay, so if you're to run something from the command line, not even the command line, the run box, then it's gonna run it. So if I throw my AAA in there, it's probably not gonna work, but we at least know it's calling run. We at least know it's calling open, which means we can mess with that. So when I dived into a particular function I saw right before the open call, I saw this thing right here. I dived into that and I see InternetCrackUrl. So it is my understanding that if I pass AAA into InternetCrackUrl, which works for like internet stuff, then it's probably not going to work. So I've come to the assumption or conclusion that, maybe I could pass URLs to it and see what happens. So I have, God, hold on a sec. This is the video, and now is the time to start video one. Where the frick is it? Video one. Okay, so I modify my thing. Now that we know it takes URLs, so we're gonna pass my website to it and see what happens. Run my code blindly, and it opens my website. So I've now successfully reverse engineered the program, and we've now found out that it takes URLs instead of just All right, let's go back to this. Okay, finally, we have download file from EasyUI It's brought to us by ASUS. We drop the thing into the disassembler, and the first thing we see it takes a string, and integer. We don't know much else about that, but when I dive into the thing, I see a bunch of weird code. For example, post message, format message. That means it's most likely a GUI app. If I instantiate it as a normal program and it's a GUI app, it's probably going to break, but I found it didn't break. It doesn't really care. So first thing I do is I modify my skeleton program. Be sure to always switch between 32 and 64-bit mode when compiling. If this is a 64-bit DLL file and you try and load it as a 32-bit program, it's just going to crash. You're going to scream, why the fuck is it working? And then you come to that conclusion. So first thing I do is I modify my skeleton program. I make it use three different arguments. Like I said, string int. So string int, and I'm going to follow along. So, like I said, I stop here, dive in, what happens? So while I was single-stepping this thing, it became quickly apparent that this thing was massive. There were a lot of different routines. It was jumping all over the place. What the fuck is going on? The only part I saw towards the beginning was something called wait for single object. Wait for single object is this thing. It's for threading. I don't know if you know anything about threading. They never teach you about threading when you're taking programming classes because it sucks. Threading is basically like you have a program, okay, like this. So imagine you have a program, right? And you like say run some really complex program, some complex code. You press start, and then you try and move the window, and then it says it's not responding and it crashes. Yeah, that sucks, right? But so someone came up with this thing called threading, right? So you have a job, some code that'll run in the background. It'll do this. So the thread will basically like run that, so that way you can move the window around or do whatever. It breaks up functionality. So we can come to the assumption that perhaps it's calling some sort of thread in order to download code or download a file. Okay. So I have this idea, I think threading, so I'm assuming the DLL, the Windows Win32 code for create thread might be present somewhere. IDA sees the reference to it, but no reference, like IDA will see the import to it, it'll look for references to it, but it's not anywhere. That really sucks. So it's being called some other crazy way. So when I'm running through the thing, running forward isn't really working, so I'm going to try working backward. So if you're single-stepping with your program, you're diving in, you're not really finding anything that you want, then you're going to try and like go backwards and maybe have get some better idea of what's going on. So we know the program is called download file, and if we know a little about Win32 code, internet read file is typically what you're going to call in order to download something off the internet. See, like I said, this is the perfect thing. It aligns perfectly. Internet read file, which I found, and this is the imports table, by the way. I found it inside internet file. It takes a file, takes a buffer, takes that. Basically, it's going to download the file. Usually, it's used in conjunction with one of these three. I looked it up. There's only this one. These other two are not inside. So open it up in our program, look for external references to it. We find this little function here, and we see this is like the craziness of the code. So once we have this particular area, we can then, like set breakpoints on it, kind of get an idea of what's going on. So at the very beginning, I was right. I realized right here that they are doing create. So what I did was I traced backwards from this one, come across, this is what's calling it, and they're using some crazy thing called AFX begin thread. AFX begin thread, it's a Win32 API, but it's not called in the traditional way. Microsoft, in their infinite knowledge, decided to add something called MFC to make programming even more complicated, and this is how they're doing it. This is how they're instantiating a new thread. I was right. So run to our external references from that, and we see download file is calling that particular instantiation of create thread. Sorry, I'm like trying to go through as fast as possible. I only got 3 minutes. I only have a few more slides, I swear. Okay, so we have our code. We have an idea of where we think we're at, where it might call this code, and we trace it backwards to it creating a new thread. So what we're going to do is we're going to set breakpoints around this particular area and follow the data we pass to it. So going back to our original program, if we have, numbers and all that, we should see it here around internet read file. So going back to our thing, internet read file, like it said, takes a handle from an open request, takes a URL, and we're going to try and see what the hell's inside when we breakpoint on it. So the first thing I saw internet read file. I saw my code. I saw this thing at the bottom. It said, I saw something inside that was called dynamically. So sometimes you'll find in your code, you won't see actual calls. You'll see something called like a register, and then you have no idea what it is. So in this particular case, you're only going to find it by stepping in a debugger, and the only way you can actually look is by single stepping and finding it. In this particular case, I'm like wondering what the fuck is that? So I didn't know it was, I dove into this, and then I found this call here, write file. So it would make sense you would call write file in tandem with internet read file, because you got to save your shit somewhere, right? So on a whim, I was wondering what kind of data can I pass to it. So in order to save time, or if you're attempting to reverse engineer a program and you want to know what data it takes and you have a kind of a vague idea what's going on, you can speed up the process considerably if you just pass certain data to it and see what happens. I see three different arguments. I pass data to it. I add a URL to one side, URL to the other side. I assume maybe one of them is a destination directory, and I say, fuck it, let's try it. And actually, that's what happened. See here towards the bottom, I passed something to it. I passed, I think I passed like my website or something like that, index, and it downloaded something. And it had this weird file name. I found I could not control the file name. It just threw in a bunch of madness. I don't think it knows what data it is, so I don't think it's a bunch of less than or equal or less than signs, but whatever. Run the code, seems to run. Open it up, it's a JPEG file. Yeah, so here I have my video. I know I'm going as fast as I can, but you have to admit though, you guys like had me set up like 5 minutes late, so I have a little bit of time. You robbed me of 5 minutes, so I'm gonna use those 5 minutes. Okay, like I said, open up my skeleton program, blindly going at it, take my website, throw it in there, add it in the destination directory, let's see what happens. Okay, testing. Nothing. Open it up. There's that weird file with the less than signs. We think we know what it is. I know what it is. I think it's a JPEG file. So I name it, whatever.jpg, and now we've actually managed to reverse engineer a program where we don't know what the hell it does, and we've actually managed to make it download code, and it's all undocumented. That's great. Okay, so did it work? Yes, it worked. So like we said, the function takes the function takes the file name, sorry, let me start again. Hell yeah, the file name of the sorry. Take that, go forward, come on. Okay, so now we know, and knowing is half the battle, and these are the works cited. I'm not always smoking crack here, but if anyone has any questions, I'll talk to you after this. I know I only have like 1 minute left, but yeah. A lot of reverse engineering DLL files. It's a lot of it's blind. What you're doing is you're taking random data and throwing in and seeing what happens and hoping for the best. In my particular case, I go after a lot of things that look interesting. If I'm writing malware, for example, I don't write malware all the time, only sometimes. I'm looking for functions that download files, that run files. You're looking for things that run winexec, create process, ShellExecute. Those are the best things to reverse engineer because then you can imitate other program functionality without it actually looking like your own. So, like I said, in this particular context, if I'm running if I'm downloading malware under the context of McAfee, who the hell would do that, right? So, that's why we do it. Do I have any particular questions in the 2 minutes or 1 minute I have left? Or is that like way too over everyone else's head? Okay, no questions, got it. Oh my God. Oh my God. Way too technical.